Hello, and welcome to the 4.2 Day 2 video. This is the last of the new information before our Unit 1 test coming up this week, so please be ready. Like I said, we're continuing with 4.2, which is focused on inverses and proving inverses through composition, but today we will also start on graphing inverses and what that looks like. So we're actually back at example number 3, which we had completed in our last video. Get my pen out. We were given that f of x is equal to 3x plus 2, but then we also found that we could find the inverse by first replacing f of x with y, switching y and x, solving for y, and then replacing y with f inverse of x. And once we did that, we found that f inverse of x was 1/3 x minus 2/3. And the last piece of information that it asks us to do here is include a graph of both of these as well as the graph of y is equal to x. So that's what we're going to do. So we're going to, oh, nope, that's not the zoom in. There we go. We are going to zoom in on this a little bit. First, I'm going to be graphing f of x. So let's see, f of x, we have 3x plus 2. That tells me we're going to have a y-intercept at 2 and a slope of 3. So I'm going to move up 3 and over 1. So this right here, drawn to, I promise, what is the best of my ability, yeah, that's good enough, is going to be f of x. Please make sure you label your graphs. And then we are also going to graph f inverse of x, which is going to, let's see, look something like this. So if we were to plug in some number in order to find our x-intercept, if we set the whole thing equal to 0, we would find that our x-intercept is 2. And we know we have a slope of 1/3, which looks something like this, and we're going to label that. But the last thing that this problem asks us to do is to also graph in the line y is equal to x. So I'm going to do that in red right here. And what you may notice is that the blue line and the green line are reflections of each other over the line y is equal to x, which is why if you take a look at the points we have, so for instance on f of x we have 0, 2, on f inverse of x we're going to have 2, 0. So I'm going to write out this information just so we can kind of remember it. So f of x and f inverse of x are reflections of each other over the line y is equal to x. So if you would like to draw that line and then reflect over that, you may do so. So this is just a little bit of information when we are graphing inverses. There are other features of these graphs that we can take a look at, for instance, like domain and range. So let's move on to page number 4. We had actually gone partway through a problem. You've just finished it in your Go Formative, and we're going to keep going on page number 4 with example 5. So we found in our last video that f of f inverse of x was in fact equal to x, and then in the Go Formative you just found out that f inverse of f of x is also equal to x. And so we weren't able to do it in the Go Formative, but let's write a conclusion sentence. Just a reminder, f of x was equal to negative 2x over x minus 1, and f inverse of x was equal to x over x plus 2. So let's write a sentence, conclusion sentence that says, since f of f inverse of x is equal to x, which is what we found in our last video, and f inverse of f of x is equal to x, which we did in our go formative. In that one, I couldn't use the inverse notation, so I just renamed it g of x. We can say that f of x and f inverse of x are inverses of each other. Excellent. So now that we have that, and we've done that whole problem, at the very bottom of the page asks us to state the domain and range of f and f inverse of x. So what I'm going to do up here at the top is I'm just going to go through and find the domains of each of them. So let's see, for f of x, I know that, hey, x minus 1, that's not supposed to be 0. You can't divide by 0. So I know that x cannot be equal to 1. And then for f inverse of x, x plus 2, that can't be 0. So we know that x cannot be equal to negative 2. So with that information below, I'm going to write the domain of each of these. So I'm going to write my information for f of x over here. So we can say the domain. Let's see. Since x can't be equal to 1, we can start at negative infinity, go all the way up 2, but not including 1. Or we can go from 1 to infinity. And then for f inverse of x, we can say that the domain, let's see, since it can't be negative 2, we can start at negative infinity all the way up to negative 2. Oops, that should be a parenthesis. Or from negative 2 to infinity. Now, since we're dealing with inverses where we're switching, flipping, reversing, finding the opposite of x and y of our operations, if we take a look at this sentence down here, whoops, there we go. Take a look at our sentence down here. The domain of f is the range of f inverse of x. Similarly, the range of f is the domain of f inverse of x. So basically what we're saying is that since domain is x and range is y, and all we've been doing is flipping or switching our x and y when finding this information, we can do the exact same thing here. So if I want to find the range, all I need to do is switch or flip my information. So for my original f of x, all the information about my x's, or in this case my domain, now become information about my range, or my y values. So the range of f inverse of x is negative infinity to 1, or 1 to infinity. And then the reverse, or inverse of that can be true, is that the x value information about our f inverse of x, if we flip or switch that around, that becomes the range, or y value information for f of x. So the range of f of x is negative infinity to negative 2, or from negative 2 to infinity. So keep thinking about flipping or switching your x and y values, and that's exactly what we're going to do on our next page when we start graphing. Now this next page with some graphs mentions something called the horizontal line test. Now in class we've talked about the vertical line test before, while you would hold your, let's say, line or lightsaber up and down and move it vertically across the graph to see if it touches the graph at more than one point. If it does, it's not a function. Well, the horizontal line test is to determine if the function is 1-to-1, meaning if the inverse is a function. So what we have right here is if we do the horizontal line test, which is intended for f of x or for the original function, if we run a horizontal line, unfortunately I don't have that, so I'm just going to have to use regular. If we run a horizontal line across our graph, if it touches it in more than one spot, then that means that the inverse is not a function. So let's check that out. So let's see, for figure 2, it says that f of x is equal to x squared. So I'm actually going to make a table first, just so that we can graph that, and I can make a point about this later. So if it's x squared, let's go from negative 2 to 2. Negative 2 squared is 4, negative 1 squared is 1, 0, 1, 4. So if we were to graph that, It's going to look something like this. So beautiful. Whoop. Now, if we want to find f inverse of x, first of all, I can make a prediction right now and go, okay, using my vertical line test, this graph, is it a function? Yes. But using my horizontal line test, oh no, it touches it in more than one spot. That means that the inverse is not going to be a function. So let's check that out. In order to find the inverse, I'm going to take my x and my y values and switch or flip them. Or something else you can do is you can reflect over the line of y is equal to x. That line got a little bit off. There we go. Of course corrected. So let's see. Let's do a new table, this time for f inverse of x. So now the y values are going to be -2, -1, 0, whoops, right on a table, 1 and 2. And the x value is going to be 4, 1, 0, 1, 4. So that's going to look something like this. And I forgot to label, so I'm going to do that. So we can see that f inverse of x, that is not a function. So our horizontal test led us true. But again, you can also reflect over the line of y equals x. And then if you wanted to do the vertical line test on your f inverse of x, again, you can see it's not a function. So let's try this with g of x. Now, g of x for our next figure, it's still the same equation, x squared, but now we have a domain restriction where x is greater than or equal to 0. So we're just getting rid of all this negative stuff. So let's see, for g of x, x and y, now we're just going to do 0, 1, and 2. So these values 0, 1, and 4. So g of x is just this part of it. And now we can either switch our x and y values, or, whoops, what of alignment, there we go. Or we can go across the line, y is equal to x, and create g inverse of x. So if I switch my x and y, my y values now become 0, 1, and 2, and my x values are 0, 1, and 4, looking something like this. So this one is in fact a function, and we can tell that by taking our horizontal line and running it across our original function. So if you're ever wondering if the inverse is also a function, run your horizontal line test. Actually, that was the last of the brand new information of this unit. So we still have a few more examples to do, but it is just practice. I want to see you do this all in one fell swoop. So we're going to do example 7 on page 6 and example 9 on page 7, and then we are done. So let's move on. So example 7 on page 6 tells us that g of x is defined by the cube root of x plus 8, and that it's 1 to 1, meaning that its inverse is also going to be a function. So our job is to do a few different things. We're going to find the inverse, and then confirm that it's an inverse, finding g of g inverse of x and g inverse of g of x, making sure they're both equal to x. Once we've done that, then we are going to sketch or graph g of x, g inverse of x, and y equals x. So this is bringing it all into one big example. So let's get started. So let's see, to find the inverse of this function, we're going to replace g of x with y. We're going to switch our x and our y. And then we're going to try to get y by itself. So first step, go from outside in. How do we get rid of a cube root? Same way we would get rid of a square root. To get rid of a square root, we're going to square it. To get rid of a cube root, we're going to cube both sides. So that's going to leave us with x cubed is equal to y plus 8. Take y by itself, subtract 8 on both sides. See, they don't all have to be as bad as example number 5. Anyway, we have that g inverse of x is equal to x cubed minus 8. So we've done our first step, we found the inverse. Now we have to prove that they are inverses. So let's do that first by finding g of g inverse of x. So let's see. That means g inverse of x is going to be on the inside. So this will be cube root of x cubed minus 8 plus 8. So we can see that here's g inverse of x, here's g inverse of x. So I've plugged that inside my g of x. Let's see, from here, under the cube root, or under the radical, we have a negative 8 and a plus 8. So this becomes the cube root of x cubed. As shown when finding the inverse, cube and cube root cancel each other out, and we just get x, because everything is undoing itself. This is a good thing, but we still have to show the other way. So let's see, g inverse of g of x is equal to the cube root of x plus 8 cubed minus 8. And again, there's our g of x, and there's our g of x plugged inside the function. So I look here, I see what's being cubed is something with a cube root, so that's going to cancel each other out. So we're left with x plus 8 minus 8, leaving us with just x. Yay, we did it. We show that both of these equal x, which means now we can brag and say that since g of g inverse of x is equal to x, and g inverse of g of x is equal to x, these functions are inverses of each other. So you're going to see some problems in the homework like this, where it's asking you to find the inverse and then prove that they are inverses, or something of this nature. Again, they don't all have to be as difficult as example number 5 from the previous video. Some of them are just like this. This is what I'm looking for. But again, we're asked to go the extra mile and graph g of x, g inverse of x, as well as the line of y is equal to x. So let's do that down below. Oops, that's still, there we go. So if I'm going to graph the line y is equal to x, that's the first thing I can do. Rough sketch, rough sketch. Sometimes it helps to sing while you graph. There we go, okay. Y is equal to x. And then if we're going to graph g of x, let's graph g inverse of x first, because that's a cube. It's just a cube function, not a cube root. So we can take x cubed and minus 8, means we're just transforming it or moving it down 8. That's what our next unit's going to be about. I'm just going to give away what's going to happen. We're going to have a point here, a point here, and a point here. It's going to look something like this. We're going to do so much more graphing next unit that I don't really care that I'm glossing over this, because we're going to go over this way more. If you'd like to make a table, you can do that. You can also go on Desmos for right now and use this for graphing. So this is our g inverse of x function, and then we can take these points if we want, and I should label this. You can take these points, switch the x and y values, and you end up over here. It's going to be a little difficult for me because normally I move my paper to do this, but when I do this, the whole video switches. There we go. So this is our g of x function. And again, you'll notice that should reflect over the line y is equal to x. So this is so much information, and all the information that we know about inverses. Now, one more thing I'm going to have you do is I'm going to have you evaluate with a graph of an inverse. So that's going to be our very last step. It's going to be example 9 on page 7. Feel free to ignore example 8. We're just not going to have time for that, unfortunately. Let's come all the way here for example 9. Oh, I forgot to take out that page. So let's go all the way here for example 9. So it's graph the inverse function of f in figure 5. Okay, so we're given points here for our original function. So here's -2, 0. Here is 2, 4. And here is -4, -4. So to graph our inverse function, even though it doesn't have like a specific function, I'm going to flip all these points. So -4, -4 becomes -4, -4. -2, 0 becomes 0, -2. And 2, 4 becomes 4, 2. So I've taken all my points, switched them, and now I'm going to connect them in order. And there we go. Okay, so now we have our inverse. So there's our f inverse. And then the instructions say, then use the sketch to find the values of f inverse below. So all of these questions down here are asking, hey, when this is my x value, what's my y value? So when my x value for f inverse is 4, what's the y value? That's right here. That's going to be -4. All right, part B. F inverse of -2. So my f inverse function, when my x value is -2, my y value looks to be -3. I'm going to leave the last 3 for you to do on the Go formative. I look forward to seeing you in class.